Today I am going to present presentation of data protocol in IoT, which is the key role in how the IoT devices connected and communicated. The introduction. The Internet of Things consists of billions of devices which are connected and communicated easily, which exchanges data. But for the communication happens smoothly, we need a protocol, set of protocols, which instructs how the exchange of data happens, and it secures and receives data between the IoT devices, servers, and cloud platforms. And PC IoT classes, you see that Blink we used software application which gives the result in a Blink many changes in the IoT device. Why data protocols are important? Ensures reliability, communication, reduces the power and bandwidth consumption, maintains data security, enables protocol devices. Whether data sends fast, securely, and continuously, or a small power efficiency package depends on the application needs. We can see in our DC class we are using just 5 volt input for the device, for the components which we use, and we can get the data easily with a minimum power supply. It is very efficient. Types of IoT data protocols. IoT used for many protocols, but common used for MQTT and COAP and HTTP and DDS. Thank you. Next will be continued by ABHISHEK.
Now I am going to explain about the basic of MQTT. First of all, the full form of MQTT is message queuing telemetry transport. Message queuing. This is useful for M2M and useful for IoT connectivity. It is a publish subscribe based protocol to transfer messages between devices. It is lightweight, so it is suited for IoT components and added for the software, and it usually runs over TCP/IP protocol. MQTT was developed by IBM and Eurotech, and MQTT is limited device, high latency and slow bandwidth. And MQTT components, first one, broker, copy, message, and client. In client, we can see publisher and subscribe. Publisher can publish any topic, and that topic was issued by the broker, and broker sends the topic to the message, and also subscriber can subscribe the any topic, one or more topic, and messages. Subscriber can receive the topic according to their subscription. And working of MQTT, and this is publisher. Example temperature, pressure, and etc. Publisher publish the topic like temperature 25.5 degrees Celsius, and MQTT broker one or more subscriber will receive from the MQTT broker topic like 25.5 degrees Celsius and MQTT advantages. It is a simple protocol for IoT devices and low network usage and low power usage, and it is lightweight protocol, so it is easy to implement in software. And application of MQTT is we can use in home automation, factory automation, medical and healthcare sector, and transport and logistics. And next part will be controller Deepak.
COAP protocol. COAP stands for Constrained Application Protocol, which is lightweight communication protocol. Works on UDP, fast and low power consumption. Which works fast and low power consumption. Used HTTP methods like get, post, put and delete. Best for which is used for sensors, smartphone devices and wearables. Main features of COAP is lightweight messages which saves power and bandwidth, reliable messages such as CON, NON and acknowledgement and reset messages. Asynchronous updates which means devices send data only when needed. Small and 4-byte data secure TTLS, where main features applications of COAP is lightweight environmental sensors and smart meter, industrial IoT and agriculture. Next part will be continued to Iwan.
And what is AMQP? It stands for Advanced Message Query Queuing Protocol. So we have seen last two protocols, it is not that much advanced. So this is advanced message. This protocol is mainly used in the banking transactions. So like we do UPI, NEFT transaction. So by doing the transaction, some messages will be forwarded to user. So that process will be handled by the advanced message querying protocol. And the main and include different applications and even in different programming languages also. So this is the architecture, how it works. So the procedure which produces a message, and based on that message, here one extra line will be the current broker. So broker exchange. So when the producer will be giving the message, so the broker will compare which section belongs to that message. So we have 4 different exchange messages. So first one is direct, topic and fan out and header. So let me explain first one, direct. So initially producer produces a message. So let me call it as a P. So now the P will be checking it with the P message which P messages will be the key message. It is also called as a binding key. So here we will check which binding key will be checked to direct method. So here if it is matched, and so it will go into the queue. Queue will be where all messages are sent to the queue. Where the consumer will be seeing that queue messages one after another. So next topic. So this topic will be having different topics. So like temperature, humidity, and other sensors. So the consumer before only he will be subscribed to some topics. Based on the topics, the procedure will send the messages and it will distribute which queue will be having the topic. So next panel, it is open source. It is like an open source. So it sends the same messages to all sends the same messages in a queue, all three queues. So now this is the header. Header will check the key value when before sending to the consumer. It is also open source. No? Routing mechanism. So we can see some frames and communication flow. So we have some frames that is open and ready, which is used to initiate and it is used to terminate sessions in link. So now link established and this will be attached and message transfer will be transferred. Flow control and reposition, flow and reposition. So link section are present which are detached and end. Connection close. So we see the advantages. So it is having delivery with availability and acknowledgement. So it is having a platform and programming language good for heterogeneous system. Supports complex routing patterns using the publish, subscribe, fan out, and base header based routing. So we have discussed that 4 header routings. So that are so decoupled and communication producers and consumer don't need to run at the same time. So helps in distinguish cloud-based IoT system. So it is a security transport, mainly is TLS. So other security also are there, but mainly is TLS, which is a transport. So other authentications, message integration or safe communication.
Really,